Hey, this is Travis the Tau Templar with Tau Stats. What are subnet pools and how do they work in Bittensor? For clarity, liquidity pools, alpha pools, and subnet pools all refer to the same thing. We're just going to use the term subnet pools. Before we start, recall that alpha is essentially a staked token in a subnet, similar to shares that pay dividends. Subnet pools are the way that we buy and sell alpha in subnets. If you want to purchase alpha in a subnet, the only way to get it is through its subnet pool. When you send tau to a pool, you'll receive alpha. When you send alpha to a pool, you'll receive tau. A subnet pool contains a bucket of tau and a bucket of alpha. Let's say there is a pool that has a total of 40 tau and 100 alpha. The price for alpha is calculated by dividing the number of tau in the pool by the number of alpha in the pool. So in our example, 40 tau divided by 100 alpha makes a price of 0.4 tau per alpha. In our example, 0.4 tau isn't quite the final price you'll be paying, but it's very close. There is a tiny flat fee for using the subnet pool, but slippage is more important to be aware of. Slippage is similar to a fee in that you'll be paying a little bit more to do your transaction. Slippage differs from fees in two ways. The amount you'll be paying in slippage is determined by the market, and no one profits from slippage. Slippage should be calculated by your wallet or app when you go to purchase alpha, but let's take a look at how it's calculated. In our example, if we send 1 tau to the pool at a price of 0.4, we might expect to get back 2.5 alpha, because 1 divided by 0.4 is 2.5. Let's go deeper. The number of tau multiplied by the number of alpha in the pool is a value we call K. It sort of represents the total liquidity in the pool. K stays the same during a transaction with the subnet pool. In our example, 40 tau multiplied by 100 alpha makes a K of 4,000. When we send 1 tau to the pool, there's now 41 tau in the pool. In order to balance the pool so that K stays the same at 4,000, we need to reduce the alpha to 97.56. This is because 41 times 97.56 keeps our K at 4,000. This reduction is a difference of 2.44 alpha. So for our 1 tau, we'll actually receive 2.44 alpha. Slippage is the difference between the expected price and what we actually received. In this example, the slippage was 0.06 alpha, or 2.4%, pretty high. To get the new price after our transaction, remember we simply divide the number of tau by the number of alpha, so 41 divided by 97.56 is 0.42 tau per alpha. Now let's reset our example and instead only purchase 0.1 tau worth of alpha. So we might expect to receive 0.25 alpha. There's now 40.1 tau in the pool. In order to balance the pool so that K stays the same at 4,000, we need to reduce the alpha to 99.751. 40.1 tau multiplied by 99.751 alpha keeps our K at 4,000. So for our 0.1 tau, we'll receive 0.249 alpha, which is a slippage of 0.001 alpha, or 0.24%, a better rate than in the previous example. The new price then becomes 0.402. Now, of course, this all works in the other direction as well. I won't bore you with the math, but if we send that same 0.249 alpha back to the pool, we might expect to receive 0.1001 tau due to the price increase from the last transaction. We will actually receive 0.1 tau, and the slippage again was 0.24%. After our transaction, the price returns to the original 0.4 tau per alpha. As participants purchase and sell alpha, the equilibrium between the two sides of the pool shifts to make sure K stays constant. The main takeaways are as follows. Instead of buying large sums of alpha at once, consider buying small amounts over time to reduce the slippage you're paying. Buying small amounts over time is a common investment strategy called dollar cost averaging, DCA, usually used to reduce exposure to volatility. But in a Bittensor subnet pool, it may help reduce slippage as well. Over time, the amount of total liquidity, or K, in every pool slowly increases via emissions. So slippage on older subnets will be lower than on newer subnets, meaning that older subnets will be cheaper as far as slippage goes to transact with. There is one key difference between a regular decentralized exchange liquidity pool and Bittensor subnet pools. No one owns the alpha nor tau in Bittensor's liquidity pools, so there is no way to add liquidity to a pool and receive a yield like there is in a traditional liquidity pool. We'll break down how emissions grow the liquidity in subnet pools in a separate video.